the basic elements that comprise
Yeah, please wait. There's some technical error. We are trying to fix it. Please bear with us.
computer audio.
Sir, you are audible. You can share the screen.
Okay, got it, sir. It's okay now. Now I'm sharing the same screen. Can you see the screen now, sir? Shall I start again? Okay. So we were here, gentlemen. Sorry for the disturbance. I don't know what happened. So this is bacteria and mesospores. So now we move forward. Filters. Now basically, to remove the dust and bacteria, we use filters, right? And broadly filters. Then the type of filters will depend on the degree of cleanness. And the degree of cleanness is defined in microns and efficiency of the filter. The lower the micron size of the particle, the better the cleanliness. And the efficiency also depends on our requirement. Now, what is the clean room? So we're going to now speak about what is the clean room. A room in which concentration of airborne particles is controlled. We control the level of cleanliness. You see, everything has a unit, right? Everything has a unit. For example, weight, you will have kg or pound. If you have liquids, we'll have liters, right? Similarly, dust in the environment must have some unit. What is that unit? We call that unit micron. The size of the dust particle we permit to enter. Size beyond this is not permitted to enter. So that is called microns, right? and the efficiency of the filters. Okay. Next point is the clean room is conducted in such a manner to minimize introduction, generation, and retention of particles inside the room. Then there must be some standards. You just can't do anything. What are the standards we normally follow in ISO 14644? The standard we follow. Clean rooms are designed to maintain extremely low levels of particulates, such as dust, airborne organisms, and vaporized particles. Clean rooms typically have a cleanliness level quantified by the number of particles per cubic meter. So we come to this. What are the parameters controlled by a clean room? Temperature, humidity, sound, vibration. These are common parameters. And specific parameters, airflow patterns, room pressure, contamination, microbial contamination, electrostatic discharge, gaseous contamination, process specifics. Now we come to clean room applications. So you see, every slide has some image, some animation to make the subject interesting. Without this, it becomes very boring. So to make it interesting, one. Number two, communication is far better through these images. Finally, retention. You don't have to just mug it up, right? Memorize it, just reading and reading. The moment you see the image or the animation, it goes into your brains and it retains there as an information, right? It goes into your software there inside. Clean room applications, first is pharmaceuticals and biotechnology. So this medicines are shown here and something is to make medicines. Second is research. These two small scientists are doing some research for research applications. Then we have microdrive semiconductors. Now we are going, in India, we're going to big way in defense manufacturing. Now defense manufacturing cannot happen without electronics. We are also going to manufacturing chips. It cannot happen without clean rooms. And if you have clean rooms, you have a massive arrangement of conveyors and this and that. And that level of cleanness has very important for these processes to be correctly manufactured, because dust is going to damage these processes. Manufacturing semiconductors, assembly of electronic components. Then we come to satellites, rockets, missiles, aeroplanes. All these sophisticated manufacturing processes require clean rooms. Then finally, we have miscellaneous applications, right? Food processing is one of them. There are many, many more. Let's talk about food processing. Then we come to another manufacturing is medical devices. You cannot manufacture medical devices without clean rooms, the highly processed equipments. Then we come to automotive spray painting, clean room. Because if dust enters this, then the dust will settle on the paint and the surface will become bad. Then we have operation theaters and an ICU. Now let me show you this in animated form. So now we have the animation out here, right? This is the operation theater. If you see carefully, the fresh air that enters this AHU has to be filtered. It comes through these filters. The room returner has to be filtered. It goes into the HU and this blower is going to deliver the air here through the supplier ducts. There'll be free filter out here. And then we have the HEPA out here. In an operation theater, the entire ceiling is full of HEPA filters. And the clean air is thrown from the top, discharged from the top, and sucked from the bottom. So if there's any dust in the room, it will settle down and go blue. It will not rise. There's no chance of dust being in the environment out here. And then we discharge the contaminated air from here, because if you're going to add fresh air, then we have to discharge the bad air. So that goes for discharge. So this is the operation theater. In this program, we also tell you how to design the lighting also, how the lighting is done. We'll come to that also. Now we come to standards, right? There have to be certain standards now which we must follow to achieve our objectives. ISO 1464. There are two standards, ISO, those who are dealing with ISO.
Sir, your voice is breaking. So I
Okay.
suggest that you be in front of the mic so
Okay.
that voice will not break.
Now it's okay.
There are some
Not-
issues regarding
Now it's
voice.
okay. Now it's okay.
Now it's okay, but I suggest not to move away from the mic.
Okay. So these are two standards. One is ISO 14644 and FS 209E. Different people follow different standards, but both are same. Now we are comparing. Now this complete comparison is given to you for your reference. At any time you can compare what is what at different degree of contamination, 0.2 micron, 0.1 micron, 0.2 micron, 0.3 micron, so on. The complete table is given to you. Now, where? These are the latest standards being followed. Now, which standard is applicable where? This standard is for this, this is for this, this is for this. All these various standards are for various applications, right? For construction, for testing, for method evaluation, for design, for operations, terms and definition. So all these standards are listed down depending on for what you want to use it for. Now we come. Okay. Now there are two sources, one external source and one is internal source. Now, how do you control them? Filtration to dilution, isolation. The three methods of control. Right. Now we come to next. So these are two standards out here. The EU standards are separate. They have their own standards, and FS to the 90 and ISO, and the comparison of all the three. Now we come to airflow patterns. This is one method. Non-unidirectional flow, right? Unidirectional flow. In some cases, the floor is also raised, right? You can see out here, raised floor. Then you come to this. Makes flow and mini environment. See, for this particular area, the laptop area has special treatment. This is extremely sensitive. So what is extremely sensitive comes here, and the rest of the room is out here. There you are. Now, so if in certain cases, this product has to be super protective. So for example, if you're manufacturing wafer of a IC chip, so that is super protective. That is kept here with maybe this is class 10, and this entire room doesn't require that level of cleanness. So as a separate system out. So we have mixed flow. Now, how the particles move from positive pressure and the formula involved in finding this. Then we come to how do you, between the clean room and the not so clean area, there has to be an airlock. See, there's an airlock between the not so clean area and the clean area. You just can't walk in from the not so clean into the clean without going through an airlock. This airlock will prevent this clean area from getting contaminated. You come into the airlock, you change your clothes, you wear special garments. The entire design is given in the forthcoming slides. If this room is pressurized, this room is not so pressurized, then the doors are not going to open so easily. Because how will you open this? If you notice something, the movement of the doors, look carefully. The door opens to the pressurized area, higher pressure. It will open towards the higher pressure. You force the door open. So when you force the door open and when you leave the door closes by the extra pressure from this side. So these are 3 pluses and 2 pluses. You see that carefully? So if I open towards the 3 pluses and I move away, the door will close because the pressure out here is more than the pressure at the airlock. The door will close. There's no chance the door will not close. Okay. So how do you place the doors, the opening of the doors? Take the case if you're in the passage now. You want to enter this room. The door is not going to open so easily. Right? If you are going to enter, okay, you open the door. Suppose you have some material, you have some material with you. For example, you're carrying some boxes of medicines and you want to enter the clean room. So, I'm carrying boxes of the product and you want to enter the clean room. Then you're going to open the door, right? Right? And then you're going to go to suppose the product is in a trolley. You open the door, you go to the trolley, the door will close again. You have the positive pressure. So there is a pressure stabilizer. You open this, then the pressure stabilizes. Then you can bring the trolley in and then close it and the door will close. So this airlock functions as a pocket where it traps all the outside dust, particle, whatever coming, and does not permit it from entering the clean room. So this pressure stabilizer is used. If you're going to carry material, okay, I have a trolley. I'll first operate the stabilizer, open the door. No, the door will not close. I've used this instrument out here. Bring in the trolley, then reoperate this, then the door will close. Pressure will increase out here and close the door. Now there's a filter. This is how. Complete construction of a kappa filter and alpha filter. Now we come about validation. How do you certify a clean room? If you have installed the filters, you run the system, how will you certify that the clean room is as per the standard or not, functioning properly or not? Then this is the method of validation. Certify, yes, the clean room is as per our requirements. So this process is defined out here. How you take it. So just see, everything is absolutely crystal clear. You take this instrument, anemometer, you have to take 5 readings. I've shown you the 5 readings, how you take it. You take it 2 here, one center, and accordingly we explain to you, right, what should be. These are velocities coming from this, and then formula is given how to work it out. The leak test, okay. Okay, we explain to you. This is the instrument is used for testing the pressure. The complete process is defined out here. Now you have to also test how much light should be there. Now on air conditioning processor, what is we got to do with this? Nothing is complete. You see, to make the system to be operational and complete, all the parameters should be taken care of. Light is also one of them, right? So we are telling you how the lighting system is done out here. Now we covered all the steps. Step one, great layout explained out here. When you come to 3, so the class, so the, all the classification for various applications is given here. What will be the class of the clean room and with respect to ISO class and FS class, and what is the application? For medical device packaging, your ISO class is 7 to 8 and FS class is 10,000 to 1 lakh. Example is given here. Okay, now we go next out here. See. Right. PS2 on ungone side. 4. All these symbols are given out here. What is EM? What is PS1? What is PS2? What is this symbol it defines? It's all given out here. And how you will look, position all these things in the line system. Uh, this is the formula of ASHRAE standard 62.1 to the. This is the formula for getting amount of ventilation required. Okay. This will makeup air is not treated. Right? Makeup air is not treated. Now we come to garments. Now see, the human being is totally covered. Cap, hood, safety glasses, mask, gloves, overall, shoe covers, boots. No part of the human body is exposed to the environment. So, so now we can take questions, sir. Neeraj ji. Hello? Hello? Hello?
So you
Neeraj ji?
can take questions one by one. You can
Yes,
take
we can take questions now. So what are the questions, sir? Can you see them?
So you can read that. You might be having on your panel.
Myself.
Yeah. And the bottom question answers.
I have chats out here.
Please read.
Can you see those questions? Neeraj ji? You've got one question now. So can you read the question, sir? Hello, Neeraj ji? Hello, I think there's a question from Mr. Pathak. I'm not able to understand exactly what you want to say. I have also purchased a clean room design book. In this book, there is a table about air change per hour, but I have a design of us approved pharma company. So we have taken the air change requirement as per ASHRAE. We have followed the ASHRAE standards. You can, they may have taken something different, but we have taken the ASHRAE standards. Basically is the clean room application. How to determine how much pressure to maintain in the clean room and also pressure difference between each rooms. That will depend. We have given a general procedure how to design. That will depend on the application. What is that product being maintained? You can have a positive pressure. I think we mentioned in the system, it should be some, we have mentioned how much inch should be there. It's there in this book. I think yes. We will get back to you on these questions, right? By mail. So class 7 and 8. We have to refer to what we have written in the book. Refer to that and we'll get back to you on this. Next question. Any more questions? Which books can I purchase? This book is available online. We will give the updated version. The earlier one was the first version. Now we'll come with the updated version, right? Very soon, in a day or two, that will be uploaded on the website for you to refer to. Now, basically, we are telling you what is the clean room about, how to design, but specifics depends on the product, on the application. Different pharma, depending if they're making some vaccine, they may require some other standards of pressurization. It depends on the viruses which they're handling. So generally, what should be the pressure differential that generally has been given out in this book? Alpha is a higher version of HEPA. It's also explained in the book. You can go to the book, you'll get it, what the alpha means. It's very much there. Any more questions? Do we need to measure, this is from Mr. Aslam, do we need to measure the HU supply airflow rate for the clean room, and what is the function of the measure of airflow as we have we measured differential pressure measurements and pressure regulations, TQ. Do we need to measure the HU supply airflow rate? Definitely you need to measure the airflow supply rate. Because you see, if the filter is, what is the degree of contamination of the filter? As you go along, the filter gets contaminated and the pressure will drop. Now, how will you know that the filter is contaminated? You have to measure the pressure across the filter to see whether it requires replacement or it does not require replacement. Definitely you need to measure it. Any more questions? There's one more out here. What should be the minimum pressure difference? You go to the book, you'll find it out. It's in the book. What the pressure difference? You have a design pressure. Let us say you have a design pressure of 40. What should be the pressure outside? Given this in the book. Any more questions? Please mention book name. That is our course material. It will be given on the website. The current one is being upgraded by this one. What you see now, the upgraded one, will be uploaded in a day or two. We'll get the upgraded one. And those who have got the old version will automatically get the upgraded version. You can call it a book, you can call it course material. We have our own course material. Go to our website and you'll get it. Any more questions? Anybody? Right. I don't think anybody has got too many questions to ask. Basically, what you're asking for is specific issues. Now, specific issues in a manufacturer depend on the product. Right? If you're making a wafer of IC, then you have to refer to the manufacturer, what the manufacturer wants. If you're going for vaccine, then you have to refer to the manufacturer, what the manufacturer wants. These are specific requirements. What we are saying, how the clean room is designed, how it is done, but what are the pressure differentials and air change, it's all because depends on the processes. For example, wafer manufacturing results in a lot of fume generation. A lot of fume generation. It's a chemical process. So those fume generation will require different air chain. Now that air chain will depend on the manufacturer. He will say what is the requirement for that particular applications. Anyone has any more questions? So if gentlemen, if you go to our website, spgblb.com, right, you can go to the courses. We have a number of courses out there, of 13, 14 courses out there, as per the requirement. You can refer to any one of them. Clean room is one of them, which you've taken up today to explain how it is done. We have tried to given as many animation pictures so that we make it. What is this? 11 new messages. Okay, yes. The bad sound is coming. Okay. Is the sound okay now? I hope sound is okay. Why we bleed off air from HU? See, very simple. If you're going to add, you see, let's understand this. An air conditioned space is a closed space, right? Totally closed. So we are going to contaminate that space. So if given fresh air, if you give fresh air, the contaminated air has to be removed. Only then the fresh air will improve the indoor air quality, right? That is why you need to bleed off the contaminated air. These standards already mentioned, this ISO standard, it will have covering everything on that regarding air change per hour for clean room. Can you explain about alpha filter? No problem. It's there in the book. We can answer that separately, complete detail. We can give alpha filter. Bit of air. How much positive pressure? This pressure is also defined out here also. What the product should be mentioned out that in that mitigation subject. So can we use app for? So we have our own heat load applications. We have a complete heat load design course out there. Regarding this app, Mr. Neeraj will get back to you on mail on this. Why bleed of air from the HU? We already mentioned why bleed of air. Please name the book. Our books are basically course materials. They are available online. So most of your questions are on air change per hour and the pressure across, all mentioned there. We'll mail back with a complete details answer. If you just mention your name and detail out here, and you mentioned this thing in the messages, get back to you on that also. Anybody else, any questions now? Any more questions, anybody? So those who have mentioned the question, the chat form, can repeat it in the question answer. Your name comes out clearly. We'll mail you all your answers accordingly. What should be the air velocity on the table operations? Now, these are all specifics. No? Now, what is the type of operation? If it's a viral operation, it'll be different pressure. If it's a standard operation, different pressure. Maybe a negative pressure or positive. But if it is a serious viral issue, then we keep a negative pressure. So these are very specific things. So regarding your question, Mr. Shankar, regarding hospitals, we have a different subject, hospitals. Hospital course material also available there. And that's a separate faculty for hospitals we have for you. Require, we can conduct a program at hospital itself. Filtration I already mentioned what it should be coverage area for filters mentioned out there. Just have to go buy the course, you'll find it all there. You've asked for kitchen exhaust. It doesn't come out here. Mr. I can't read out your name. So I'll just address to you, Mr. Anonymous Attendee. Okay. Hi, may I know what is the common phase velocity baseline for HU supply air for a clean room? And the kitchen exhaust food. You see, basic fundamental is that the return air should be at approximately 500 loss FPM and the supply should be at 1500 FPM. The velocity has got nothing to do with the application. Velocity has got to do with the sound level. So normally we take supply air velocity at 1500 SPM and return air velocity at 500 FPM. Kitchen hood also, we take at the suction, we take 500 FPM. One more question. How many hours of constant is there clean room in your course? Or the clean room. We have not measured the old version. I don't exactly remember exactly what it is. It should be around 1 hour. Mr. Pathak is asking how many hours of constant content is there in the clean room. I think the video content is for 1 hour, approximately 1 hour. It should be 1 hour. Any more questions? So I hope you found the program interesting. 2 more new messages. How to calculate exhaust filtration and quantity in a clean room. It's there in the book, in the course material. How many hours of constant is there in the course? Already there, mentioned it there. There are possibly 1 hour, it's 1 hour. Any more questions? Now you can ask. We have covered this. If you have any other question regarding what the courses we are doing, then go to our website. Mr. Aslam, sir, what is your advice for HVAC design for specified clean rooms? Again, I'm saying we are not going into specific applications. We are saying what is a clean room, how the basic design of a clean room, what are the basic parameters, what are the standards, what are the garments, what is pressurization. But when you go to specifics, then you have to refer to the manufacturer for the specifics. They'll be near about the standard parameter, slightly different because of the requirement. I give an example of wafer manufacturing. Very caustic fumes come out from the wafer manufacturing. So that has to be exhausted. That rate of exhaust and accordingly the rate of input will come. Accordingly, the number of air changes will change accordingly. You have just a comfort application, right? Then first of all, if you go to our ventilation slides that we mentioned, we don't go as per air change per hour. We go as per the ASHRAE formula that is given there. Right? If you want me, I'll go back to that. It's here, I think. Just a minute. Going back. Just show you. Ventilation range pusher. Now we are from this ASHRAE standard 62.1.2019. We are not going by air change method. We are going by this method. Ventilation breathing zone, outside air flow rate per person, number of persons per zone, outside flow. So we are going by this formula, not by air change per hour. These are the latest methods of finding the ventilation rate. Okay, gentlemen, you can go to that for that, right? In question are there. You can go to, we will get back to you. Should you share your mail ID again if you reach out? Okay, I'll get in touch with Mr. Neeraj Shukla, right? You just give us your email ID out here. We'll get back to you. Just Mr. Anonymous attendee, please give your email ID out here. We'll get back to you on this. This new book, you call it a book, I call it a course material. And in a day or two, we'll be uploading that also. Ready? Almost ready. So gentlemen, all those who have asked for air change per hour, right? You can go to this method. This does speak of air change per hour. It speaks of the zones, ventilation breathing zone, airflow zone, number of people. This is the standard followed by HVAC 62.12019. This is to be used now. Air change method was the older method. The details of this, how to go about it, is in the course material. You will have to buy. 3 more chats out here. We have given those tests, pressurizing tests, leak tests are given out there. Now, Mr. Shadman 1052, just along with an email ID, please write down exactly what you wanted out. Those who are giving the email ID also mention what exactly is the requirement. Okay. So there are so many questions out here. So you are requested, please share the PPT on mail. So this PPT is not going to be shared to you, right? It's not shareable. The request, please share this PPT on this. No, we don't share the PPT. Please share this PPT. No, we don't share the PPT. You are all welcome to procure the course material, right? You'll get the video version and you'll get the PDF copy. PPT is our copyright, is not shared by anybody with anybody. These tests are required for clean room validation. Can you please, along with this question, can you please give your email ID? Anybody having those questions, along with the question, please give your email ID. It becomes easy for me to identify. No? Okay, I've got it. So Mr. Samir, yes, we'll get back to you on these questions. All those with specific questions, we'll try and help you out with those specific questions. Along with this question, please give your email ID. It becomes easy to identify. Anyone has any questions? Somebody was there for heat load estimation. We have got a very nice course material for heat load. It's all in animated form. Even the psychromatics is animated, very simple to understand. And those who go for a heat load estimation, we give for the heat load, we give a complete, totally automatic, 99.9% automatic, pre-linked Excel sheet. The moment you fill your basic data in the Excel sheet, the results come, you get the tonnage, and you also get the dehumidified CFM also. Totally different, absolutely mind-blowing Excel sheet available for you to use. So most of the question, those who are asking for air change per hour, you have to refer to this standard. It covers everything. Air change per hour is now old method. New method, you have to get standard 201 of HVAC has to be followed. Anybody, any other question you can ask? Besides this, if you have any, a very interesting course on electrical essentials. Every HVAC engineer should have basic knowledge of electricals. Without electricals, they will have a difficult time. So there is any material, of course, for sir, we have it. We will get back to you. But Samir, we have a very good course on heat load estimation, totally animated, beautiful psychromatics. All the lines are moving automatically, very easy to understand, supported by totally automatic Excel sheet, formula linked. So you don't have to worry about the formulas. You don't have to worry about the factors. It's all there. In the heat load, what we normally is as we assume factors. U factor we are assuming there in this this thing, our calculation, we explain to you how you calculate that factor, because the factor depends on the building material. What is the building material? Right? How thick is the plaster? How thick is a brick wall? So different buildings have different building materials. So we explain to you how you calculate that U factor without getting into the detailed calculation U factor, how you can estimate the heat load. Normally we just assume take it at this, take it at that. That is not the ideal method of doing it. I was speaking of essential electricals. What are the basic controls, how the controls works, what is voltage, what is earth, what is electrification. An air conditioning engineer should be knowing what is electrification. And when you're working at site, how you test the earth, all the basic electricals are there. Plant layout, what about cables, laying of cables, everything is there based, and all our contents are practical oriented. Go to SBBL.com. When to use HEPA filter instead of HU on the when to use HEPA filter. Now that is specified in the classification of what class you have is written there. If you go to our course material, this course material, we have mentioned for this classification, you have to use this filter. It's all mentioned there. You don't have to worry about this question. The type of filter will depend on the classification. Class will depend on the usage. You want class 10, you want class 100, you want class 1000, you want class 10,000, you want class 1 lakh. Now the class what you want will be the requirement of the product. This product, they'll say this product, I want this class of clean room. Then that class of clean room, you go to our charts, you'll mention that you need HEPA filter of this specification. It's written there. Anyway, we'll get back to you. We'll get back to you on this also. We'll tell you exactly what this is about. Any more questions? Those who are on the site activities, right? The site activities, we have course on troubleshooting. We have a MEP course that covers everything from center plants, unitary systems, installation, service, heat load, electricals, even in the what you call this installation, installation, duct design, everything is covered. Even duct design, chill water piping design, condenser. We basically do complete practical oriented. For example, working a site. So working a site, you're a site engineer, right? What is the best technology to control microbes and AHU? Okay, we'll get back to you on this also. How to do a pressure and area classification room wise. So this is all specifics, what they want. It depends on the type of contamination. But general pressurization is mentioned in this course material. This should be the pressurization for it to function. Sorry, sir, we cannot share this PPT. It is our priority, what you copyright. All these animations are made by us with a lot of efforts. These animations are not available from Google or YouTube or whatever. We do not take anything from the internet. We don't take the help of Google. We make everything. All the drawings are made by us. No Google drawings are here. We make the drawings. We do the paintings. And we animate it. We make the movements the way we want it to explain. That you see what we are under one roof. The designer, the engineer, we communicate accordingly and do the job. We don't outsource anything. All those who are interested in the course material will get the course material, right? And all our all our videos have animations, images, text, and voiceover. The video speaking to you. At any point, you can pause, re-listen, and do it again. And will be supported by a PDF copy. So we have an MEP course that covers everything. Design, fabrication of ducts is covered. Can you tell us in short, how do humans work with low RH areas? I won't be knowing how humans work. Low RH will result in dry skin. That's it. Normally comfort RH. Wherever there are human beings, they have a comfort RH, right? Comfort RH is 50 to 60%. Below 50, it becomes dry. You have below 50, then you have it results in static pressure. That also defeated now, no longer required. We have duct design, we have electricals, we have everything. You just go to our spgblv.com, you'll get all the details, all the course material, whatever you want to do, it's available. I think there are 13, 14 sub courses. Those who want a Hindi course, there are some Hindi courses also in Hindi language, right? We have window AC, we have split AC, we have a lot of things are there. But you just open that website, you get it all. Any more questions? One more new message. Go through. Flow through and draw through. Most all HUs are draw through. Nobody does go through, right? Now, this is a typical example. It's a very good question this gentleman asked. Blow through. You see, I'll give you that. Window AC is what? the condenser side, right? It is blow through, and a split AC condenser is draw through. Both examples are there. All HUs are blow through. You suck the air through the coil, and then you don't blow the air through the coil. Now, why do people use the air through the coil? That is called induced draft. Air flowing through the coil is induced draft. And we blow the coil with the air through the coil, it's called forced draft. Induced draft is better because the time of heat transfer takes place in a heat exchanger. Let's say the cooling coil HU. So more the time air is in contact with the coil, the better the efficiency, better the heat transfer. So induced draft is much more efficient than forced draft. So you'll find all the HUs. I've never seen a forced HU. All the HUs, the air is sucked through the coil. So the air that is sucked through the coil, the suction air, comes at a velocity of 500 FPM. So velocity and the discharge air is 1500 FPM. So the suction air has more contact time with the cooling coil fins and hence better heat transfer, hence better efficiency. Some more questions out here also. What should they have lost with table operation theater? Okay. And how do we calculate filtration air quantity for a clean? That filtration rate, that chapter is there in this course material. So may I know what are the common phase velocity baseline? This standard all HUs 500 FPM suction and 1500 FPM discharge. How many hours of constant is the clean room? I've already mentioned. So what the device HVAC that you mentioned? What? Mr. Anonymous Andy, just give your email ID. We'll get back to you on this question. We'll share our mail ID with you on your mail ID. I need the following classification. Kindly revert. Okay, you have given. How to decide how much pressure we need to maintain and pressure difference between each rooms. We'll give the general design applications. How to decide how much should be the exhaust air and makeup air quantity for a specific clean room. Air filtration is already mentioned out there. Makeup air and exhaust air. Whatever you make up has to be exhausted. Plus the positive pressure. We have mentioned it out there. Anyone else with questions? So gentlemen, we don't have questions, shall we call it a day? So you can always refer to our website for any clarification. All those who have given the email ID will get reward from us. Shall we wind up, gentlemen? Thank you very much for your valuable time. It is our effort to give animated products so it becomes easier to understand. Normally what a text requires, let us say 3-4 A4 sheets, one slide of our animated video covers everything. If you see carefully, for example, if you even see this slide, let me explain to you. Let me explain this to you. You just look at this slide. It explains everything. The door openings explains everything. Which side the door must open. Now to explain this in a text form would take 3-4 A4 sheets of 4-5 slides. One slide explains everything. Explain now again out here. I'll go through one of them. So this explains everything. What measurement? What you need to measure? It's explained out here only. You see the image, you'll find it out. What you need to do is done out here. Now this instrument is drawn by us. This instrument is exactly the way you'll find in your hand the moment you hold it. Exactly the way it happens. Nothing different. Two more chats out here. Step 3. Okay, just a minute. Just give me a minute. Why do you add humidifier after a cooling coil? Why not before? We'll get back to the very good questions. Yes. Many people have asked this question. A very good question. Right? Okay, now somebody asked for step 3 now. Determine space pressurization. Here it is written out here. To ensure this, now let me read this out. You have to maintain 0.03 to 0.05 inch water gauge, which is equivalent to 7.5 to 13 pascals of positive pressure. The positive pressure what you maintain is 7.5 to 13 pascals. Or an inch of water column is 0.3 to 0.5 between the clean room and the adjoining dirtier room. It's mentioned out here. Let me just there you are. It's mentioned out here. To ensure this, the exhaust air volume should not be more than 15% of the makeup volume. There you are. There was a question out there regarding what should be the exhaust or makeup. 15% more. Makeup, right? 15% more than the exhaust air volume should not be more than 15% of the makeup volume. Pressure and stabilization given out here. Any more? Any more questions? There's one more question out here. $17. So we have answered all your questions. We'll get back to you definitely on your mail ID given to us, right? We hope you enjoyed this webinar. Shall we call it a day now? Okay, gentlemen, thank you very much for your precious time, right? And look forward to hearing from you again. Thank you very much. Thank you. So now we are winding up. Okay. Thank you, gentlemen. There are quite a few still waiting. If you have any questions, you can ask. Still have a few minutes left. Any questions, WhatsApp, you can still ask. So there are no questions. Thank you, gentlemen. Wish you good day. Thank you. So There are more chats about. There were one more few. Okay, I'll just come back again. What is the future scope? Somebody asked, what is future scope of a design engineer? Now, whoever asked this question, please share your email ID. I've written a paper on sustainable energy and the future of air conditioning industry. I will share that with you. This gentleman, whoever asked this question, want to learn Rivet, and we'll get back to you whether we are doing that or not. Mr. Johnson, what is the question? Mail ID is here. Okay, goodbye. Oji. More new message come here. Thank you. Okay, thank you very much. Sure, now we'll wind up. Thank you. Thank you, gentlemen. Have a nice day.